Hello, this is Ball Milling by Nicole Campos. How does ball milling work? Ball mills are often used for crushing and grinding materials into an extremely fine form and blending materials. It is a solvent-free mechanochemical procedure which allows for better yield of products compared to classical solution-based methods. A mechanochemical reaction is a chemical reaction that's induced by the direct absorption of mechanical energy. Therefore, the reactive milling of solids involves the process of reducing a material to smaller particles, which creates more surface area and surface energy. And this is what a ball mill looks like in this little graphic over here. So there are different parts to a ball mill, which include a three-phase motor right over here, which is connected to a gearbox. The gearbox is then connected to two gears that ultimately connect to this bigger ring gear. The ring gear is attached to the ball mill drum, and the ball mill drum is normally made of steel. There are two bearings that support the drum at the front and the back. The material is fed through the inlet at this end, and the discharging part is at the opposite end over here. There are balls inside of the drum that are made of stainless steel or sometimes rubber, and one end is graded and the other one isn't. Let's see, in this graphic over here, you can see the balls that are inside of the drum, and in this upper right-hand corner, they're made of steel. The graded end is normally at the output end over here, and the inside is lined with armor. As the three-phase motor rotates, it's controlled by a drive that increases or decreases the rotation speed of the drum, so that as the ball mill rotates, the balls are held at the side by centrifugal force, and at some point, the weight causes them to drop and then tumble. So as this happens, a substance is fed into the ball mill at the input end, and this substance can either be wet, where water is added to form a slurry, which occupies roughly half of the ball mill's volume, and it's normally made of 3 parts solid and 1 part water. Or the material can be dry, in which it contains very little water or simply moisture. So as the ball moves, they grind the material and they move around through the ball mill as this is happening. And the substance is fed in at an even rate. So once a slurry is made and ground enough, it passes through this grate at this end, and it acts as a filter where larger particles are left behind, and the smaller particles pass through the grate and are expelled through the output end. Rotation happens at a relatively low speed of around 30 to 40 RPM, depending on the drum's diameter. So smaller drums will operate quicker, while larger drums tend to operate slower. Where is it used? Ball mills are used in engineering, mining, and pharmaceutical industries. Ball mills are used for mineral processing, creating building materials, and for final grinding of drugs. It's also used in production lines for powders like cement, silicates, fertilizer, and glass ceramics. Strengths and limitations. The strengths of ball mills are that they have a higher product yield compared to classical liquid phase methods, and they also have a better selectivity and simple workup procedure. It produces a very fine powder as well, and this method has many applications. And there are also environmental implications of the chemical process, which is why ball milling is considered a greener solution that is still effective compared to other methods. The limitations are that they can be difficult to handle and inconvenient depending on the size of the ball mill. Grinding also involves a high specific consumption of energy, and this energy is mainly consumed on the wear of the balls and wall armor. as well as the friction and heating of the material. Another issue is that milling time in tumbler mills often takes longer to accomplish the same level of blending that can be achieved by other methods, but the overall productivity and yield is still greater with ball mills. And its capacity, ball mills are very practical because it involves an oxidation reduction, and in most cases it's scalable up to production scale, which is why it has industrial applications. And these are my resources for the presentation, and thank you all for listening.